In section 1.1, I want to introduce you to the book. This is what the front cover of the book looks like. It's the Mario Triola Elementary Statistics book. This is a introductory statistics class. We're going to hit topics, and we're going to go about a mile wide covering topics in here, but we're only going to go about an inch deep. And any one of the topics we discuss in here, they could delve down deeper into forming deeper understanding, a course with deeper understanding of any one particular topic that we discuss in this course. The first thing we're going to look at in opening up is looking at some possible abuses of statistics. In 1.1, they have a graphic that looks like what I have copied right here. It's figure 1.1 in your book. And then I'm asked, what is wrong with this picture, with this graphic? Reading this chart, it says, have you ever been hit by a computer virus? This is the number of responses for yes, and they're measured in tens of thousands, and the number of responses that indicate no over here. And it looks like, looking at this picture, that maybe we have 3 times as many yeses as we have no's, just looking at the sizes here. But if we look at the number of actual respondents, we see that there's not 3 times as many yeses as there are no's. As a matter of fact, there's not even 2 times as many yeses as we have no's. Because if we doubled the 63,000, that would be putting us well over 120,000, and this is only 106,000. When we don't start our axes for scaling at 0, then that can introduce bias or cause a misleading representation. The axis throws this off, and because we're only looking at the top half of the graph, the scaling looks more pronounced than what it really is. This is an example of how statistics can be used to misguide the public, to give the impression that more people have experienced computer viruses than those who have not. That's something that you need to look out for whenever you're studying statistics. In this preview, we say that in this context, the terms sample and population have special meaning. Formal definitions for these and other basic terms will be given here. In this chapter, we will look at some of the ways to describe data. Getting the general terminology down, data is what we have when we have a collection of observations, such as measurements, genders, or survey responses. Data, by the way, is a plural term. The singular version of this word would be datum. So make sure you get your subject-verb agreement just right. The data are representing the sample, however, that particular datum is an outlier. Statistics, the science of planning studies and experiments, obtaining data, and then organizing and summarizing, presenting, analyzing, interpreting, and drawing conclusions based on that data, is called the science of statistics. We also use statistics in another way when we talk about a particular numerical value that comes from a sample. So we could have sample statistics that correspond or correlate to particular population parameters. The population is the complete collection of all measures or data that are being considered. Whenever we study an entire population, what we're doing is we're gathering or collecting a census. A census is when we survey everybody in our population, and if we have a subset of that population, we would call that subset a sample. So our population parameters, mu, p, and sigma, correspond to our sample statistic, x bar, p hat, and s. These things correlate. The mu and the x bar both mean an average value. The p and the p hat both mean a proportion or a percentage. And the sigma, lowercase sigma, and the lowercase s both represent standard deviations. I don't expect you to be completely familiar with all of these terms yet. I'm just introducing them right now. So if we survey everybody in a population, what we've done is we've taken a census. A census is very difficult to attain. Every 10 years or so, the U.S. government tries to take a census, and that's where they gather information from every member of the country. A sample, on the other hand, is a sub-collection of members selected from a population. It's much easier to round up a sub-collection and take a sample and gather sample statistics than it is to survey a population and look at population parameters.